If we took this expression, the very first thing you want to look to do is remove any common factor. So you look, there's three terms here. Are there any factors that are common with all three of these terms? Numerically, it's a 3 and then the variable x. So you know you can take a 3x out of every single one of these terms. Okay, so the process really of factoring is just distributing out the common factors. Okay, and the thing to keep in mind is whenever you remove common factors, whatever's remaining when you remove that common factor has to have the exact same form as the original expression. So this original expression were three terms combined. That means when you remove this common factor of 3x, there still has to be three terms combined in that remaining factor. Okay? So when you look at that, factoring out just means that you are going to go into each individual term and you're going to divide each of those terms by the common factor. And you're going to find out what's going to remain when that happens. So if you take out a 3x from 6x, what's left? When you divide that through, you're left with just a 2. What about a 12x squared divided by 3x? A negative 4x. And then finally, a negative 3x cubed divided by 3x, negative x squared. And so that's what you wind up doing anytime you remove common factors. You take out and divide out whatever that common factor is, find out what remains. Okay, now, it is possible when you're looking at these that if this was a question on a test, this may not be the form of the answer. Oftentimes, factors are written in standard form, so highest power to lowest, okay? And oftentimes they're written with a positive leading coefficient. So if we were to look at this and reorder this trinomial factor so that it's standard form, you would have a negative x squared written first, followed by the x term, followed by the constant. So it's possible this is what the answer choice would look like. But again, oftentimes the leading coefficients of trinomial or multi-term factors are going to be positives. So it's possible that you may have an answer choice where this negative is taken out of all these terms as well. If the negative was taken out and applied in front here, you would change the sign of each individual term. So you get an x squared, a positive 4x, and a negative 2. In all likelihood, this blue form would usually be the solution form, okay, written with the positive leading coefficient for your multi-term polynomials. All right, questions on this, just removing common factors? Okay, on page 25 of your text, I want you to try sample problem number 8 really quickly, please. And after you get an answer, go ahead and compare, see if you got the same thing as those sitting near you. All right, let's take a look at this last example really quickly. Okay, how many of you distributed first, combined like terms, and then factored? Okay, so that's one way to approach it. If, however, you can view this as the same format that we did here, we have two groups of factors separated by an addition or subtraction symbol. Okay, so we're combining two groups of factors. Well, between those two groups, are there any common factors? So the x plus 1 is in common. Okay, so what you could do is you could think of that as your common factor, just like what we did here, the common factor of 3. If you remove your common factor, whatever's left in your remaining factor has to have the same form as the original. The original was the difference of two groups, right? So when you remove a factor of x plus 1 from this first group, what's going to be left? Just the 8x. And in this second group, what's going to be left? A negative 3. And so if you think of it in those terms, it allows you to find your factors very simply. Okay, now, one of the things that we're going to be doing in the last section of this chapter is based on being able to think in these terms, being able to find when multiple factors are grouped like this, that you can remove a common factor and find what remains. And again, what remains happens to be right here, an 8x and a minus 3. And so you do want to get in the habit of being able to do this. It'll be more useful for some of the things that will follow. I'm guessing that most of you came up with answers that were identical to your classmates on this if you compared. So what I want to do as far as demonstrating this is to simply take a look at the calculator and how you would use the calculator for factoring. And so if you have yours out, you can take it out here really quickly and I'll talk through how to factor with your calculator. Your calculator has a built-in factoring function. So that's located under this Algebra tab, F2, and it's the second one, factor. And if you just enter that function and then type the expression like you have it, it will provide you with the factors. So if I type in factor 15x to the fourth plus 25x squared, just close it off and hit enter, it will give me my factors. So 5x squared plus, or times 3x squared plus 5. I want you to try B on your own. See if you can confirm that you got the right factored form using your calculator. All right, guys. How many of you found that it didn't give you what you were expecting? Okay. Here's the thing. The TI-89 doesn't understand some things. And one of the things it doesn't understand is implied multiplication. It cannot tell if you enter ABX cubed. It doesn't understand that you meant A times B times X. It thinks you labeled your variable ABX. All one thing. So you need to be very careful. Anytime you're implying multiplication of letters or variables, you have to specifically tell it. And so if you entered that command as factor A, and then you use the multiply button, B, multiply button, X to the power of 3, minus 2A, multiply X to the power of 2. Now notice I didn't put I didn't hit the multiply key between the 2 and the A. Your calculator understands the implied multiplication of a number coefficient then a letter. It just doesn't understand a letter and a letter, and it wouldn't understand a letter and a number. So if you wanted to express x or 2 times x as x2, it would think that you're labeling a variable x2. It doesn't understand that you're trying to say it's multiplying there. So you have to explicitly tell it when you're multiplying, especially when you're dealing with letters. So here my final term would be 3a. Again, it understands the coefficient of 3, but you have to place a multiply between the b and another multiply before the x. Now if you enter it this way and you hit the enter, now it should confirm exactly what you got by hand, which is ax times the quantity bx squared minus 2x plus 3b.